in this lesson, I would like to explore texture effects with you. We've seen previously how we can assign a texture to a base mesh, but today I would like to go much further and show how to add effects on top of these texture, or even create basically an image out of a composition of different shaders that we can apply to as a material to a mesh, and also how we can improve or beautify a scene by adding some post-processing effects. So as usual, we'll start with our main loop, and if we want to get back to the basics, let's use our trusty cube. And we know we need to add a basic material to be able to apply texture to it. So I'm connecting this, should have a cube. Let's put this to white. And if I want now to assign a texture to this, in the basic material input port, I can click on this button, and by default I have basically a base texture, and from the library files I can pick, for instance, the beach here. So here I've applied a texture to each faces of my cube, and if I want to see that, I can put an orbit controls and verify that my image is applied on each of the faces of the cube. So far, so good. Now, what I said before is that we would like to maybe modify basically how this texture looks like before we apply it to our cube. So the way to do this is to use an operator called image compose. But before doing that, I want to separate the rendering of my geometry here from the composition, from the image modification pipe. So this is why I create a sequence. And as I was saying, we will start with dropping an image compose, which is a core op of Cables. And because it's under the texture effect namespace, and if you open here texture effects, you should see a lot of ops. So there's a lot of things you can do with textures in Cables. So we cannot, of course, cover everything, but let me talk about the basics. So how does this op work? It's a bit strange, I would say, because whatever we put below it, the ending result will arrive here as a texture. So imagine this op as doing I would say, if you open Photoshop and you have a lot of layers, an image compose, it's basically a stack of layers, a stack of effects that you can put, and you would get the result of all the effects into this output here, the texture out. So let me demonstrate simply. If I want to now create, just put the texture as in my stack, I can connect it here to the base texture. It's pretty cool because you will see that automatically the image compose takes the size of the image here. So if I want to visualize what's happening, we know that we can do a vis texture. So, and nothing changed, right? It's exactly the same beach that we had at the beginning. The size is 1K square, and I put it as an input here, and notice that the size of my image compose, so the size of my layer, automatically took the size of the input image. So far, so good. Now, let's say that I want to modify the hue of this image. I want to change the colors. I would go below it, type a new, basically a texture effect, and now start to play with this hue. So notice, this is my input image. I'm applying an effect, and the result goes through this port here. So this now, for Cables, is a texture. It's exactly the same as if I took it from an image. So I can connect it here to a base material, and we notice that I can actually change in real time how my texture looks like on screen. I'm going to activate the high-res display because my screen needs it to be clearer. If you don't, as I said before, don't necessarily activate this if you don't have a Retina screen, because it adds more computations to cables. But for me, there's a big difference when I do this. So as I was saying, in the U here, now I can start to animate the value. And of course, this could be driven by a timer, or it would be driven by a sidebar. So if we just make a timer here, and we put, I don't know, a timer, it has to be between 0 and 1. So if I put modulo 1, I should only have the part, before only the floating point part. And now automatically I will rotate through the U, and I can reduce the speed a bit to make it easy on the eyes. So, okay, I've added one effect here. And I could add more. I could say here now I want to make it brighter. So for instance, I could add, it's exactly this way I was saying at the beginning, the Photoshop thing. I'm adding effects on top of my layer, or my layer stack, because you can actually put many different images in the same image compose. So here, to demonstrate, I can push the brightness of my image, reduce or put more contrast, and you see it's basically stacked. All the effects are stacked on top of each other. The result goes here. Okay, so this is pretty easy. There are many, as I said before, effects, but here we always use an input texture. What if we want to create our own image and we don't need to load any kind of asset? So we'll basically have to use some kind of effects to create some patterns or some things that we can use and apply to our cube here. So let me create another image compose, because as always, you can create as many as it's not as many as you want, but as many as your computer supports, basically, passes, and a new, basically, not passes, but yeah, new image compose pipeline, I would say. And here this time, I'm not gonna use an input textures as input. So for two reasons. In most cases, you don't necessarily want to have the image compose to be the canvas. So the canvas means this image compose is going to be as big as the rendering window here. So if I move this, make it bigger, you notice that this will change. So let me demonstrate again. All right, so the issue with this is that when you want to create effects, sometimes you can get away with a smaller size, and actually a computer-friendly size, which is always a power of 2. So I would say image compose, if you can get away with the slow, like for instance 512 by 512, go for it instead of having some weird resolution images, because of course now if I put the same image compose and I put this in full screen on my 4K screen, it will take like much more resources, and maybe I don't need this depending on what I want to achieve. So I would say the image compose here, let me set a manual size, for instance. And if I go back here, I can say, no, this one is going to be 512 by 512. If I now do a vis texture here, even if it's empty, let me try again. Vis texture. You notice that if I click here, now the size of the VIX texture really depends on what I put as input here, and not dependent on the image that I put at the beginning or the canvas size. So now, okay, we have a new pipeline of image compose. What else could we try? So the first thing I want to show you is like, what if I want to draw the image? Like I want to reuse my same beach here, but I want to control the size, and I don't want to put as input for whatever reason. It's one of the most handy ops in the image compose pipeline. I would call it the draw image, which is simply a way to draw an image and then a mask if you need one to hide part of the image. And notice that this image here will be downscaled to the size of my image compose here. So, okay, so far so good, a bit of the same thing. What else could we create? Now, as I said before, instead of reusing an image, we could create our own texture based on the available ops that we have in Cables. And most likely when you want to create some kind of generative patterns, you always use some kind of noise. And we have different noises, noise textures, either directly a texture or as a texture effect, like below the image compose. You see if FBM noise, for noise, there's like tons of them. Let's say we use the cellular noise, for instance, or whatever, like this one. What if I connect it here? Of course, now the noise is basically being drawn on top of my image, right? And if I play with the blend mode here, I'm telling Cables Hash, like, do you need to add the values? Do you need to multiply them? And you see here, depending on the way I blend the layers, exactly like Photoshop, this is the output. So let me disconnect this and take the, here, the image compose to see what it looks like. So depending on, and you see that the name of the op will also change according to the blend mode. So if I put normal, it's like this, and I have just the noise, but I can do any of the blend mode. You see here, they are basically all of them that you have in Photoshop plus one or two extra. So it's a blend noise, so I can multiply. It's just black and white, so it will multiply both images, and you would see it through basically. And you see and notice that the image here is flipped. You can change that either in the cube here, there's a flip, or you can also flip the image there. It doesn't really matter. So, okay, we are adding an effect, a noise on top of our image. I don't want to use my draw image anymore, so I'm gonna go back to the normal thing. And I want to add a gradient. I want to color this noise, for instance. So if I tap gradient, I would have many options, and what I want is the gradient from the texture effect. And of course, by putting it on top of my noise, I'm losing my noise in a way. So it's a bit silly not to use the chain, but what I want to do is to multiply the two so that I have some kind of noise that is colored, and I have still the same pattern. Okay, I like it. Maybe I can animate the noise as well, because the noise is a pattern that can be animated in all directions. So let me demonstrate. If I go here, I can move in X, I can move in Y, I can move in Z, which is most likely the one you want. Because if I connect now the timer to my Z, automatically I'm going through the noise and animating the value very smoothly. So this is already something that is interesting for us to play. So what if I want to, you see I'm stacking different effects, but here I only have one output. So if I want to inspect what I'm doing at each stage, what I can do is put an image compose snapshot, which basically outputs intermediate textures, so we can really understand what's going on. First, I'm drawing the image. This is the result. Then I'm creating a cellular noise, and here is the result. And then finally, I have a gradient. I'm connecting here, and I can visualize the gradient, which is multiplied. But if I go back to normal, this is my gradient. And now I decide that I'm blending with the one, the whatever is before. So I'm multiplying everything. And of course, the latest image compose snapshot of the chain is always the same as the texture out here. So this is pretty handy to debug when you start to stack effects and you're not really sure what is what each thing is doing, especially when you start to play with blend modes. It can get messy very quickly. But here I like my gradient, looks like, but what I don't like is that it's a bit dark. So I'm gonna just remove this, and as we see here, I can just put a brightness contrast thing and push it. So I'm gonna reduce the contrast to half as usual, but maybe push, the brightness a bit like this. Okay. So now I have some kind of a generative texture that I can use. And if I didn't really play with the noise here, right? But we can, for instance, put more harmonics. We can also push the scale a bit up, so it would look like, you know, smaller and smaller. I can make tileable, so like the edges should work. If you don't remove the gradient, they look uniform, and you can basically put many cubes next to each other, and they will seem like it's only one big texture. Here I don't really care. So here I have my cube, my generative texture. Now what I would like to do is to apply this now to my mesh instancer. So it's exactly the same as just applying on the one cube, right? We know how to do this quickly. So let's imagine that I'm not using a cube, but instead I'm using a sphere. And you notice that the texture is stretched, and of course you see that there is when it wraps around, you would see the seam here, and there's no like easy way basically to it depends on how you made the texture. Basically you can play some with the way the texture is being wrapped and filtered. So for instance, if I put nearest, I will get a bit more detail. Mid mapping, I'm not sure it works here, but mid mapping, it depends basically how far you are from the object, and it will create different versions of the texture. So to achieve the good result, maybe we could play with the gradient, and instead of having a gradient that goes from, you know, left to right, if we put a radial gradient like this, then of course you would have less seam, because the noise wraps around, but because it's very similar on both sides, it looks more uniform. So I would go like this to make it a bit more uniform as a planet, I would say. And something we can play with, remember that I talked about the size of my image compose here. If I decide that I reduce one side of the image, then I'm stretching in one direction. So it creates another effect like this, right? Because I'm stretching, like this is my final texture that I'm wrapping around. So it creates some weird, but not that bad effect on the sphere here. So if I put back 512, but I maybe reduce this part, you will see that I'm stretching in the other axis, and it looks more like something that like an illusion of speed or something going around as a sphere, which I think works for the demonstration here. So you see how playing with the size of the image compose can really influence, of course, the end result that would stretch the texture or not. So as I was saying, we would like to apply this on many spheres. So we know how to do this easily. We have, for instance, the point sphere random, which is just a way of creating points in space around the sphere, basically. We know how to put a mesh instancer. We've done this many times. So I'm going to create a mesh instancer. I'm going to connect my sphere. I'm going to not render it anymore because it's going to be rendered by the mesh instancer. I'm going to connect this here. And of course, I have spheres are way too big, so I can reduce here the radius, right? And notice that they all have the same orientation, so I could also rotate individual instances, and I can do this by doing a random number array. Random number array here, taking the same size, so I want an array 3, and I want to rotate around, let's say, only the one of the axes, let's say this one, or maybe a bit of Z here in degrees. Connect this here to the rotation. And now I have rotated spheres. But to give a bit of a variation, I would say, right? In the gradient itself, these are the colors, but I can always click and randomize my gradient. So I could also map this, for instance, to a mouse click. So I can do mouse and take the left click button and connect to randomize. So each time that I click and I'll drag, I will basically randomize the colors. Okay, this is just to illustrate my point. So now we have a shape and we have applied our texture to our many shapes. What if what if I want that to apply an effect, but to the whole scene and not just one individual sphere that I basically copy many times over? I will need to do something else, because there is no, how can I create a texture out of this, out of my scene here? So fortunately, Cables has another op called render to texture. So I'm gonna put this here, and basically it's kind of the same thing. It's not an image compose. This is a way for us just to create a texture. So if I visualize my texture here, notice when I'm playing with the mouse here, everything rotates in the texture and I don't have any background. So because the black background here came from the default main loop, but actually here there is no clear color, right? So, but if I put it here, which I don't recommend you do, here I'm basically putting the color inside and then rendering everything to the texture. But it's not a good thing. We would like to have all the objects basically separated so that we can apply an effect and maybe recombine with the background later if we need to, right? So I would never put the clear color here, and I would use this as a basically transparent layer. And now that we have a render to texture, well, we need to apply our effects. So how do I put this back to the screen? Well, it's exactly the same technique. Basically, we would create an image compose. So I can just copy and paste it. But this time I want the image compose to take the whole canvas, right? So here I would put it in canvas size. And if I just connect it here, well, my image compose goes there and nothing really changed. And we know we're going to apply some effects because this is the whole point. But if I just want to apply whatever I render here to this rectangle here, there is an op called full screen rectangle. Full screen. That you connect usually at the end. And then I connect my texture to it. And it looks exactly as before, basically. It's just more costly to do this. But now that we have a way to have a texture, now we can add some post-processing effect. So basically after the scene is rendered, we have it to a texture, we apply some cool effects, and then we finally put it back to the full screen rectangle here. So let's create some effects to make this scene a bit better. I would say to change the color and maybe make the sphere glow, for instance. So as we know, I need to put an image compose. And before basically first render my image put it in my image compose, take the output of the image compose and put it back to my full screen rectangle, making sure, of course, that the image compose has the right canvas size. Okay. So like we did nothing here. We just basically create an extra step, but now we have the image compose pipeline. So let's say I want to make it more bright here. I can simply start by putting brightness as before. Push it, right? So now, okay, my spheres are a bit more bright. I can also make it more vibrant. So, you know, like the colors are richer and deeper. So there is an op called vibrance. And you see, okay, this is maybe a bit too much. And notice that it's important. I mean, there is an order, right? You can, you don't necessarily have the same effect if you invert one or the other, depending on how they stack, right? So here it's way too big. You see, on the opposite, it's too low. But yeah, I'm pushing this a bit. Yeah, okay. What else could we do? We could maybe a bit sharpen the edges. I'm just showing you some random effects you can add, right? So I'm not sure if you see that on video, but it should, I'm gonna play with this. You see how you have like more, like actually if it's too high, it creates a bit of like moire patterns, or like the aliasing. You see that it's not very clear, and all the lines are basically being mixed up and create some weird patterns because it's too sharp basically. But right, if I reduce it a bit, you can play with this to emphasize the lines here, or not. if you don't want to. Okay, so that's cool. It's already getting, being much brighter. Like, check the difference between the two textures, right? This is what we get like from the drawing that we of the scene, and now this is what we have with the post processing. So already it adds some pop, right, to the image. And something that I told you before is that we could make it glow. So this is I'm going to show you this technique, and to do that we need another image compose, basically before, and then we're going to stack this effect that we create on top of the final scene, then we render. So let me demonstrate. It's the same thing. I need the image compose. I can draw the image by just copying it here, as we did before. Now the technique here, let's visualize before we do anything. Let's also take this texture and put it here, so we see what's happening. What we need to do here, if you want to make it glow, the technique is to actually blur the image and add the blur on top of the original clear and sharp image. So what I can do is I can also add the Luma key, which is another op that you don't know, which is basically here, remove darkest or brightest part of the image. If you don't want to basically glow the black here, you can decide, how much of the black do you want to remove it? Do you want to, or sometimes it's too bright and you want to reduce the brightness. So by playing with this, it's not really needed here, but by playing with this Luma key, you will change slightly. So let's finish the pipeline and you would see the difference. I'm gonna start to tweak these parameters a bit. What we need, as I said before, to make a glow is to make a blur. So we have to, the blur is very expensive though, so you have to be careful with this. There is a new op called one pass blur, which is actually pretty cool because it's very efficient. It's cheap. So because imagine here, we have to render the whole image, then blur this image, and then add it on top. So each time you create this image compose, which is as big as the canvas, it's quite heavy for the GPU. Here we have an efficient blur, which is like a one pass blur, and then you can play with the radius here. So if I push it to 10, you see it starts to get a bit blurry here. It's not as good, I have to be honest, with the regular blur, but I wanted to show you this. Let's see. And I can also put a bit of more vibrance to make it glowy a bit more. So, right, like this. So, okay, this is something we need to add on top of our image. So how do we do this? Well, we know now because we can draw an image. So the draw image doesn't have to be with the image that we load. It can just basically a way to pass one image compose onto another. And here I need to add the two. I need to add, because if I put just normal, then of course I will override my whole image, which is then useless. But if I add the two, I'm adding my original image plus the one we have before. So let's compare. This is without, and now connecting the glow. And you see it starts to glow. Right, so, and of course we can play with the other parameters. I can reduce also the glow here. I can play with more or less vibrance to make it stronger. I can also, as I said, move the radius, put it a bit bigger or smaller to change how it glows. And let's check now the effect of the Luma key. If I push it more or less, you should see a different, like here, like there's no dark at all. If I push it, I'm removing the dark a bit from the, here I'm removing the dark from the glow, and then I'm letting the dark values shine through the regular rendered sphere. So by playing with the Luma key, you can really tune this kind of parameters. So here my dark values are sharp, and it looks like edges or thin lines, and because I've removed them from this part here. So the other technique, so the one pass blur is pretty good. If you can get away with it, do it. The other one is called fast blur. So if I go here, we can compare the two. So I'm gonna remove this, and here you can have both directions, so vertically and horizontally. And you notice that this is actually a bit more refined. Visually, this glows, I would say, a bit better, and you can definitely see the difference here with the because we actually have not only one pass here. This is one pass, but we have 2, 3 passes. So it looks more like blobby, and you can also clamp some values if you don't want the blur to go way too far. But yeah, if you now look at the end result, I would say this is a higher quality glow, but it's of course more costly. So it depends. This is the post-processing. What we do in like client projects is we always have some kind of tab, or we can basically tune these parameters with the sidebar. And depending on the performance of the patch, we can disable the post-processing. For instance, if you are on a mobile phone or low GPU device, so if you have a crappy computer, then we cannot put all the shiny effects. If you can support it, then we activate, for instance, the glow, which is, as you now understand, quite heavy on the GPU here. Of course, the more passes, the heavier it gets, but the more refined the end result would be. So I hope that it's a bit clearer, this image compose pipeline. It was a bit difficult at the beginning, I remember, when I first learned about it. But I hope that through these simple examples, you have a much better understanding on how it works, and that you can really, just if you want to format your patches, think of, I'm creating my textures, I'm applying to the scene, and then at the end, I always add the post-process. I mean, I don't always add, but I add the post-processing at the end. It's always about rendering to texture, put in image compose, put some effects, and then rendering to a full screen rectangle, for instance. So yeah, I hope that this is informative, and I'll see you in the next one.